Hey, pre-cal students. This week's assignment involves a new topic called the vector dot product, which you have not seen before. So that's what this video is about. And I'm going to show you how to calculate the dot product of two vectors, whatever the heck that is. So on the screen, you see the component form of two vectors, and we're going to define an operation on these two vectors called the dot product. Mathematically, the dot product is actually really simple. Here's all you're going to do when you want to calculate the dot product. You're going to multiply the x coordinate times this x coordinate, and then you're going to multiply the y coordinate times this y coordinate. So x coordinate times x coordinate, y coordinate times y coordinate, and you're going to add those two quantities together. Now the proper notation for the dot product looks like this. We have vector u, and then we're actually going to put a dot. That's why it's called the dot product. So vector u dot vector v, and the calculation is, let's see, 3 times 5, and then you add negative 2 times 2. So this just turns into arithmetic. 3 times 5 is 15. Negative 2 times positive 2 is negative 4. So we have 15 minus 4 is 11. That's how you calculate the dot product of two vectors if they're written in component form. So notice the answer that you get is just a number. The obvious question is, well, what the heck does this number mean? It has to have some sort of meaning. We could talk about the dot product for a couple of weeks probably, but we're just going to do the calculations for now, because there's another side of the coin when you're talking about the dot product. In component form, it's really, really simple. So let's see what else we can do with the dot product. Now, if you have two vectors and they're not written in component form, if you're thinking about them in magnitude and direction form, there's a different interpretation of the dot product. So let's draw a picture of two vectors. So let's say we have vector, I'll use the same letters, vector u, and let's say the magnitude of vector u is maybe 3, so the length of this arrow is 3. And then how about we have vector v, and let's say that the magnitude of vector v is equal to 4. So the length of this arrow is 4. Now, another interpretation of the dot product, and this is the interpretation that a science person would have, is that the dot product of u and v, so again, it's the same notation, it's u dot v, it's equal to the magnitude of vector u times the magnitude of vector v times the cosine of the angle that's between them. So let's go back to our diagram, and let's just say that the angle between these two vectors is 30 degrees. If we happen to know that information, then you can do this calculation really quickly. It's almost as easy as the previous component form. So the magnitude of u, let's say it's 3. The magnitude of v, we said that was 4. And if we happen to know the angle between the two vectors, say it was 30 degrees, we'd have 3 times 4 times the cosine of 30 degrees. So that'd be 3 times 4, and the cosine of 30 degrees is square root 3 over 2. So as a calculation, 3 times 4 is 12, but then we're dividing by 2. So this would be 6 multiplied by the square root of 3. So obviously there's a lot more going on with the dot product of two vectors, given that the mathematical component form, x times x plus y times y, seems really simple. But obviously there's some geometry going on as well. I'm not going to get into the details right now, I just want to show you the basics of calculating the dot product of two vectors, and in the next video you'll see how those are connected to each other. So, see you then.